because we are a company, we cannot present a deep research review. And sorry about that. Here is going to be a presentation, but it's not going to be a deep research. All three, if we collaborate, we are going to do research together, deep research together. The aim of this meeting is to collaborate. If I understood correctly, it's going to be hopefully we can collaborate with scientists, university, academia, and business or technology. And my name is Turan Ustak. I have a PhD in genetics from Istanbul University. And since 2008, besides my other research, I am working with the bacteria, collecting bacteria all over the world, from the mountains, from the lakes, from the sea, salty water, all kinds of environment. Alaska, Himalayas, Kilimanjaro, North Africa, South Africa, South America, all over the world. We have a big collection of bacteria from all over the world. And as scientists, as I said, in the company, now I need to present what we have in our system. This is our research laboratories. We are a startup company. We are not a big company, it's a startup company, but we have good facilities in our laboratory. Molecular genetics lab, we have the molecular genetics laboratories and also microbiology research laboratory. And also, we don't have too much fancy tools like we have. University has lots of fancy tools, HPLC, FPLC, genome sequencing stuff, but we outsource this kind of stuff to the Texas A&M, University of Houston, University of Texas, and some special laboratories here with this kind of collaboration.
Where are these labs located?
Richmond, Texas, south of Houston, in between Fulshire and Tea. We have microbiology laboratories, and we have lots of bioreactors because since we are dealing with bacteria, we have to have the bioreactors. Why we need this kind of fancy stuff? Because there are lots of companies in the market. They sell microbial fertilizer. The microbial fertilizer that we have in the market is full of pathogen alpha. Most of them, if you sequence them with a small mice and just sequencing, you can profile them. You can see lots of pathogen in this kind of product. That's why we have to have this kind of seminar. This is not a factory, it's a proof of concept pilot plant. It's not a real factory. But the capacity of this facility is 50,000 liters per month. All is stainless steel, 3-stage stainless steel, pure, ultra pure air, filtered air, DI water, reverse osmosis plus DI, and product is pure without whatever we add from the beginning. At the end, we have this bacteria in our product. Transaction, CIP, SIP. So this is our product. This is our product in IVC tank and need ready to ship to customers. Our focus is we have a focus. The focus is not just produce bacteria and sell the bacteria. It's going to be easy to produce and sell the bacteria because, but to send just bacteria to nature is not going to work because environment is very harsh. High temperature, low altitude, low oxygen, high oxygen, high temperature is very harsh. We need to work on bacteria. The focus of the company, the research of the company is using microorganisms and the plant symbiotic relationship and its effect on rubisco and carbon fixation are active areas of our ongoing research. This is our main focus, and we are working on this one stage for several years.
Can you explain what rubisco is for those of us who don't?
It's the carbon section, using carbon converting into the CR6 cycle. Yes. And we have a product called Raspberry. Raspberry is a brand name. Under Raspberry, we have different products. Not Raspberry just not only one product. We have Raspberry brand and different products. What we have in the Raspberry, we have tried to increase the peptides, different peptides in the product. Some of those peptides are being cloned. We clone peptides in the plasmid, we put E. coli, and we produce them, purify them, and take the product. You know, peptides work like hormones, like we have this kind of stuff in the product. Biostimulants that we have in the product comes from bacteria that we use. As I said at the beginning, we have 8,000 over 8,000 bacteria in our library, around 300 fungi in this, and some bacteria in our collection. Amino acid vitamins, we try to increase this kind of stuff with Saccharomyces, distribute Saccharomyces, add more amino acid into our product. Bacteria, fungi, enzymes. Enzymes, we have close to 84 engineered enzymes in our facility, but we don't use all of them right now for the product because we need to get it to be.
So is this fertilizer for the plants or for the
Plants? Sorry,
For the plants.
sorry, for the plant, not for animals. No, sorry.
So what major nutrient is it going to supply to the plants? Is it organic compound or is it?
Organic compound, organic.
Organic.
Organic. So this is completely organic. It's,
I mean, what I mean to say is like, because the fertilizers, it has nitrogen, phosphorus, or
you are very right.
potassium.
Yeah.
So, I mean, and other like, molybdenum, like, micronutrients, there are other micronutrients. So what is it like stimulant, like, for example, enzymatic or like?
So the challenge today is if you will say biostimulant in the United States, we don't know what that is.
Maybe I'm wrong, like, right word, but
The
like-
Europeans have settled this, right?
Okay.
In the US, the registration process is really challenging at the moment because is it a plant growth regulator? Is it a fertilizer? There's any number of questions that come from this. So today we have to register the product as a biofertilizer, knowing full well that, if I have to go out and sell it as a fertilizer, it won't compete very well. 1% nitrogen against fertilizer dealers doesn't play well. So we have to call it a biofertilizer. In fact, it's a biostimulant. So then you see all these other things come into play.
Okay, so it's more like a hormonal kind of.
It can be various. It can be hormones, it can be, supporting or food for the microbes in the rhizosphere. I mean, when you read the papers, you will find there are certain microbes making secondary metabolites that can express the genes in the host plant. The same thing like our probiotics, right? The human health and some gut bacteria can switch on and off the genes in the brain also, right? So something like that. So it's a new area in agriculture.
You're right, Kurt. We cannot call it as a fertilizer, the fertilizer has at least 3% according to European regulation. Nitrogen, we don't have 3% nitrogen, it's like 0%. Nitrogen, organic nitrogen, we cannot add chemical nitrogen for that. Because only is not going to accept it. Because we have only for this products. But the plus that we add externally add to the product are behave like hormones. That's why we clone this into the E. coli system and we produce in bioreactor and we supply it. That time we actually add to the product before. All the polysaccharides that we have are here, some of them are. We try to add, increase the amount of the oligosaccharides in the product, which is some of them have like hormones, they have affinity to some other stuff, and we increase this kind of stuff. The extra, we add this kind of stuff. Enzymes, most of enzymes that we have in products right now is coming from the bacteria. It forms bacteria metabolism to produce some enzymes. But we have recombinant enzymes right now close to 80 for recombinant engineering enzyme. About this enzyme, we have the trace element externally. We have to add this kind of. But the issue is this one trace element that we add is not too much, because if you add too much trace element or some other chemical compound into the product, we are going to kill the bacteria. And 1 liter is for 1 acre. The amount that we trace element that we add to the product is not going to work in the field, but we add some trace element. Fungicide, pesticide, insecticide levels, right? Compound that we have is working for this kind of stuff also. Recipe brand has products that work on the field for bioremediation. This experiment has been done by another company, by Diaz in Chicago. Dr. Leonard and sent this data. He asked for the product because this kind of company, we know each other, we collaborate sometimes, we work together, and we compete, but we work together. He said, Duran, okay, and your product is better than mine, this is what it is. Here's the result. Blue one is our product. And one of our scientific group and led by Dr. Gori Lapadikar. She's from transfer from the university, Dr. Gori. And she's main project is with biodegradation of pesticide in the soil and also liquid on foliar. And those are some enzymes. Those are just some of those kind of enzymes, recombinant enzyme. Most of enzymes that we are using and we are thermostable. If they are not thermostable, we try to make them thermostable. That we use classic regular genetics techniques, mutation, tested, combination of changing the amino acid and check the activity. If the activity is okay, for the next step. Those are the some pesticides that we can easily degrade in the soil. Foliar, we are not cannot say we are okay in the foliar. Yes, up to a certain point we are okay, but in the soil definitely. And I think we are okay. We are good in this kind of stuff. Same experiment done by Dr. Gori, recombinant protein that she expressed and purified. the same enzyme, Western blood result of the same enzymes. Phosphate solubilization is a big problem in the world. I think we are going to mention about this problem also. And there's a big demand to solubilize phosphate, mineralized phosphate in the soil. We are using phytes, everybody better than the phyte is a good enzyme, also work for the animals in the soil. One of them is phytes that we are using is phytes, and we use some other combination. All of them are thermostable. We use the thermostable enzymes. Phytes that we are, and this is the right phosphate from the nature, directly from nature, we use in our experiment. And this product is working well, definitely is working well. This is a classic GFP that you are using also in your laboratories, and purified and recombinant enzyme that we are using, one of them. And the enzyme that we are using, we are just not thermostable. They have to be UV resistant always, but we work with the molecule. We work on the molecule, try to use different combination of the conformation of the RNA, and we try to make it the enzyme resist to heat, UV, and harsh condition. That's why I put this slide here. And also to do this kind of stuff is for a company is lots of money, and we are not a big company, we are a small team, but results are definitely close. This is one of these because after the cloning the enzyme into the system, into your plasmid, and we need to transfer this one into the bacteria. Either it can stay as an episome, or we have to integrate it into the genomic system. Most really use bacillus system, but right now we don't have any modified bacillus in our product because we need to be resistant to the stage. We are using bacillus. We are engineering the bacillus genome. We are entering whatever we have, whatever we needed into the bacillus system, and also yeast. We are using different bacillus for different enzymes for different reasons. After integrating your genome into the system, into the bacillus, and you have to work on it for another months and for a year to get a clear cell line, to make it a cell line, because if it's not a cell line, your bioreactor is, if your bioreactor is 5,000 liters, then you inoculate, give it to your bioreactor. At the end of process, you are not going to have your enzyme. Yes, bacteria is going to work, but bacteria is going to, bacterial genome system is going to remove your integrated genome, and it's going to be just pure bacillus without your enzyme. Creating cell line is harsh, challenging for us because of that. There are some other enzyme that we are used, different tests that we have purity, the activity, stability, thermostability, and later we need to purify our enzyme because some of them need to be in powder form. We cannot use this enzyme directly as a edited for the product. It has to be pure and in powder form. One of them is manganese, and I'm sure you know manganese is very good enzyme for the animal and for the fish, also for the phosphate, for some other the carbohydrates of degradation, degradation enzyme. I forgot to mention the thermostability range that we are working is 65 Celsius to 125 Celsius. Our range is 65 to 100. Our enzyme, most of our enzyme is all 65. We work at 65 Celsius. One is that we have it is 132 Celsius, working at 132 Celsius for 30 minutes. Very robust enzyme. This is our enzyme is temperature is 195. But this is nothing like a Celsius Fahrenheit. And in the direction that we need to go, we can go all together, or this is our direction. Can we mitigate the negative effect of the oxygen on Rubusco and nitrogen fixing pathways in symbiotic bacteria to help the plant for the more CO2 sequestration? So the Rubusco system sometimes confused with all without capturing carbon dioxide, was with oxygen, and this one is this problem reduces the efficiency of photosynthesis, and at the end, less CO2 sequestration. Also, as you know, oxygen has a problem with the nitrogen fixing pathway. It looks as a common pathway. Rubusco and nitrogen fixing in some bacteria, very close, that work in the same environment. Oxygen involved in the same problem at the same time. We are trying to remove oxygen from the microenvironment with our product. This is one of our focus, but it's a challenging project in academia. It's a very difficult project. We are not scientists, and we need a lot of effort for this one. This is the result that we get from this our experiment. We increase the photosynthetic activity. This experiment done by Dr. Henry, and he's an agronomist from Nebraska. Now he left us, unfortunately. I'm upset about our science. He left for a good, better company. Yeah, United States.
So where is the symbiosis, the microbial symbiosis? Is it in the leaf?
The root.
The root.
In the root.
And that symbiosis can affect photosynthesis?
Yes, definitely. Can affect photosynthesis.
And reduce coefficiency?
Yes, yes.
Sorry.
Definitely, yes.
So, for example, in maize, Rubisco is efficient because oxygen is isolated.
Maize is a good example of Rubisco efficiency. That maize, soybean, this kind of stuff.
And
yes.
This research has been going on for many years, and it's very challenging.
Very challenging. But there are good paper about this.
I don't see how microbial activity in the soil can affect Rubisco activity in the leaf. It is because the oxygen and the carbon dioxide are getting through the stomata directly into the Rubisco. So what can interfere this reaction? I don't know. This is
It's a good question, Mark. That's why we need to focus on this. We are working on this one. There are many companies working on this one. Yeah.
I think maybe also the scenario could be different from
C3 and C4 climate.
Yeah. So the issue is in C3, and previous core can access both oxygen and carbon dioxide. So oxygen cannot be isolated in C3 from the
No, isolation, no. If I'm mistaken you, sorry. We are not gonna remove the oxygen. You cannot remove the oxygen because if wherever the oxygen radicals you find there is some reaction is going there, some enzymatic reaction is there. It means we should do it. We have good things going there, but the microenvironment, if the oxygen level is increased, certain point involves in the reverse phase and try to it's a balance. If in the pool, if you have all oxygen, it tries to say, okay, because okay, it's a feedback. It's a kind of feedback. Okay, reduce your speed. But this is the question is this: Can we play with this balance? Compare our sequestration carbon. This is what we are people try to do. Not just us.
Okay.
Not just us. Yeah, there are good papers. Yeah.
Oh, okay.
Challenging area. I think so offered that that's why we are here to your university and our company can work on this project. Work with symbiosis and also, but just that symbiosis is not going. That symbiosis is not going to work with this. We have to use recombinant biotechnology technique. Not just the bacteria, not just bacteria alone is not going to be enough in this project. Biotech.
So is nitrogen fixation increasing chlorophyll content, but through increasing chlorophyll content, increasing photosynthesis?
Sorry.
So what I mean is that if the nitrogen fixing bacteria increases the nitrogen supply to the plant, that nitrogen can increase chlorophyll production, and that chlorophyll production can increase the photosynthesis. But directly affecting the score, viscous function, oxygen, carbon dioxide concentration in the leaf, there is big disconnect because one thing is happening in the soil.
Yes.
The other is in the atmosphere, in the leaf. So, and visco by itself, So I think that's very interesting. This is the first time I'm hearing about this. I'm a physiologist.
The symbiosis between Robusco and correlation between symbiosis and Robusco is, yeah, there are lots of papers, sure. It's not our claim. But our claim is we can increase this one, we can increase symbiosis with biotechnology. That's my claim. That's a known area, it's not my claim. That's a known area. Any question? You can just picture of it here, because you are comfortable. Yeah, you know.
Question for Ms. Samuel, you were talking about peptide degrading enzyme. Here. My question is about application, enzyme specificity is one issue, but how this is feasible to apply pesticide degrading enzymes given the heterogeneous environment in agriculture and data.
It's a challenge, definitely. I agree with you, it's a challenge. And Bob is here. Maybe he can answer this.
I've got an interesting example to show you.
Thank you.
Well, I just said, my name is Bud Wiley. I don't have a PhD, I've got a business degree. So backing into the plant science world, just because I was interested. I've worked in agriculture for 50 years, from started riding grandpa's tractor on the fender, and so my dad had a ranch, and so all of this ag knowledge has come from School of Hard Knocks and Fruit. So I learned about the money side of it. And so from, the research, it has to, somewhere along the way, it has to be commercialized. Or money stops, right? So I was fortunate enough a couple of years ago, I've been interested in sustainability in agriculture for a number of years. Fortunate enough a couple of years ago to get into biotechnology and go to the School of Grant. It's interesting to have known what some of the problems are. I just phosphate solubilizing enzyme that we're working on. I get to test first stuff that gets to go to the field. For a lot of what I've done in my life has been in more arid environments. Grew up in North Central Texas, worked in Texas Panhandle, across the southwestern U.S. in a lot of cases, a lot of high pH soil environments. So routinely, phosphorus is tied up. So I got to put this out in the field. I was at a field day yesterday where we applied some on some cotton. And the man that put it down, he said, I forgot where I put it. I didn't put the stake. When we walked across the field, oh, there it is. Literally, that's like this. Just getting early availability of phosphorus. So this whole notion of stimulating biology, putting enzymes into the soil, making it bioavailable is literally the cutting edge, the next step in agriculture. So it's a really interesting environment to work in, to get to work directly with producers, but then to go back and, telling you what did I see, and it's maybe towards the end of my career and work on something that's innovative and fun to do with.
Yeah.
I say,
Is this one?
yeah.
Oh, well, you want to look at your laptop? Had his slide there.
You got a jump drive.
Well, yeah, he did. That's what I just used, but it's pretty. Yeah. It's
Oh, good, good. You can find out. That's fine. What was it about it?
I'll just let me join Zoom on here. Just give me like 3 minutes.
Yeah.
Just for information. If you work directly in the plant side. Microbiology. I'm just trying to get a sense of the or extension. I'm trying to understand who. What your field was.
We have plant physiologist, animal reproductive biologist, carbon sequestration, water genetics, carbon sequestration, analytics. Yeah, animal genetics.
Okay, so I'm gonna tell you for my simple non-scientific thing, and I think all of you would probably agree. Carbon sequestration is a function of biomass production. Everything. So. I find that we can understand. More plants. But if you want to ask the question, how do you sequester carbon? We gotta have soil health. How do you have food security in the world? We gotta have soil health. So it's been interesting to me in the changes. Function on the lab side of it. In a lot of cases, I send samples to the soil lab. Soil producers. Because at the end of the day, that's, all of the work that we can do is all going to come down to can a farmer somewhere in the world or a livestock producer somewhere in the world do something that makes a difference. And we all, yes, that we all have an interest.
What about the nutrition value? What about the nutrition value of it?
Exactly. All right. You want nutrition? You got to get, plants to get better nutrition, right? So.
So, some of the things that we see in these, this being able to stimulate biology with some of the things that is tolerance to salt. Well, in a lot of places in the world that we would all like to see, better production in soil, salt is a problem. It's a health problem in soil. So we've seen some interesting things dealing with soils that have higher EC levels. We can alleviate some of the stress in these plants where they tolerate this environment better. So this gets back to the idea of producing more biomass. This was a trial that I did down in Weslaco with Texas A&M. So what we were looking at was tomato, and we used what we would expect to be a normal rate, and we used a 2x rate of the product. The interesting response was when I went out there to look at the trial about halfway through, I drive up and I see so this is a replicated trial. I drive up and see these scattered plots that are blooming. I'm thinking, well, all right, one of the treatments is working well. Well, I get there and start looking at the numbers. It's not the treated ones that are blooming. Maybe we have a problem. No, the problem wasn't that they were blooming. Everything that was not blooming had already set a lot of tomatoes. So this ability to take up nutrients quicker translated into plants going through processes quicker. And I see this routinely. We've got a protocol for producing cantaloupes and watermelons. And I'll eat every one of them that didn't a week earlier. It's just amazing how plants respond when you get this, the symbiotic reaction of enzymes breaking down, making things available. You get some biology working. So this translates into real world. Plants mature quicker. In the case of these tomatoes, the higher level treatments actually led to a more favorable relationship between the bricks and the acid levels in the tomatoes, which the 1x rate would have been something like if you were going to make juice or ketchup or something, you want a whole lot. But if you wanted high quality tomatoes that would sit on a shelf longer, the higher rate indicated that it would produce that. So I can't tell you why. I can just tell you the response. Plants that got better nutrition responded better. And so to your point about nutrition, if you have higher bricks, less acid, that would have been a more favorable nutrition profile. So in peppers, we've seen the same thing, higher accumulation of solids. Cantaloupes routinely see higher bricks numbers.
What is sweeter?
Now,
What is sweeter, like, you know,
well, that's what bricks, so bricks is measuring sugar levels.
but I'm talking, like, you explain this to a layman farmer.
Yeah.
To get them to understand what this is going to be doing, you have to be able to show more of hands-on, saying, hey, this is one of the watermelons we grow, the texture, the sweetness of it. They need to see that, because when you're showing this, I see baskets of tomatoes, but you're not making it for me to like, okay.
Well, so the big thing that whenever I went to work for the company, they said, this works in high saline, high pH environments. You want to guess where the best case for that is in Texas? The Rio Grande Valley. They water with salty water. Because water in Rio Grande is routinely 900 to 1100 parts per million of salt. And they're in a high pH environment. Oh, if this is what this product does, that's where I'm going. All right, so the fastest response you can see is in vegetables. So that's why I've worked with tomato, cantaloupe, watermelon, peppers, things that, you know, number one, they're high value, but number two, you see a response pretty quickly. But to your point, yeah, they taste better. They're sweeter. And the interesting thing is you mature more of them quicker. So from a grower perspective,
That's market faster.
they get to market faster. And so there's some real sensitivities there. But the other piece is, what's a more mature cantaloupe to you? Sweeter and tastes better. All right, they mature quicker, they taste better. I mean, and you can aside from tasting, you can measure it and prove that to be the case. Because if you have higher bricks, that's a direct indicator of sugar.
So is
Sorry.
the tomatoes.
Yes.
Is the chemical, the press freeze applied to the tomato, the fruits, or to the plant?
We applied it to the soil.
So
This was now I'll tell you, we've done some things. Primarily it's focused on soil treatment. I've done some things as a foliar treatment, and I'll show you that here in just a second. And I really I'll be honest with you, I really struggled with how can something work in the soil and in the plant, or applied to the plant. He can tell you all the science, I just know what happens. So my introduction into the Prairie View area was from a lady that used to be a professor here who went to Algeria with us last summer. So this was in the Sahara Desert. All right, and I'll show you a picture of the farms shortly. And by the way, the Sahara is a little bit of sand, and they're farming this. Very low organic matter. There's a lot of zeros in it. But we're seeing response, better root growth. All right, if you get better root growth, what are you going to have? It's going to be a real quick equation to opportunity to increase organic matter, i.e. carbon. These plants were treated the same soil, the same everything, with the exception of our biostimulant product. And the same thing in Canada on canola, better root growth, And I'm kind of driving on this because I know you're in, you know, you have some work going on with Shell with carbon sequestration. You know, I tell farmers all the time, carbon sequestration is driven more by roots. I mean, you got to have the top growing, you got to drive it into the ground with roots, but don't plow that stuff up, you know. And so, but we see a routine amount of roots increase by using product. All right, so to your question about foliar, these are some citrus trees down in the Rio Grande Valley that froze 2 years ago. Everybody probably remember that little event. So the tree on the left has not been treated. The tree on the right, whenever I met this guy, and I know nothing about citrus trees. All I know is these trees look bad. I've got a product that's got some amino acids, some micronutrients in it, low levels of nitrogen in a tree with a wrecked vascular system from the freeze. Let's just try spraying the foliar on it, spraying it as a foliar. Well, in a couple of months, they started acting like they might live. So then we started this regimen of soil treatments like we would normally think of doing it. Well, this was last spring, about May. And you can see the difference. These trees are literally from here to that podium apart. The only thing that separates them is a little berm where they watered 2 rows of trees at a time. So there's a little water berm in there. So, but as far as fertility, water, all the other management pieces are all the same with the exception of what we've done with this product. Now, they got their first pick this year. I mean, last year, we were just trying to make the trees survive. The freeze had hit them right when they got froze. So they didn't have any blooms on them to make fruit last year. So this year, whenever they picked them, the they ring pick them. It's a size pick on these trees. And whenever they ring picked them, the untreated ones looked like they were going to be 40 to 50% of what they would expect the harvest to be. And the treated trees were going to be 70 to 80%. So for a citrus grower, this was significant because if he's going to take these trees out, it's going to cost him about $6,500 an acre, and he's 5 years away from his next harvest. Now, I will openly tell you, we spend a whole lot more on these trees than would make sense to a normal grower. But when he put that in perspective, what that could be on an economic basis. So this is nutrition, but it's also driven, microbial. So these are some changes we've seen in blueberries and raspberries. And again, fruits and vegetables are fun to work with because you see a really quick response. This is some corn in Germany. So
It's hard to see the guy over there, isn't it? Same guy.
Same day. And this was so you think about what does this mean longer term? This is some barley that was planted in Turkey.
This line right across here.
It's the difference of being treated. There was some garlic grown in this field the season before.
That line
was a treatment line of raspberry. They didn't fertilize, they didn't put raspberry on it yet. That was the residual difference. And you start from upgrading the microbial activities, making things happen in soil that's supposed to happen. So all this research stuff actually commercializes. So this is a cotton field, and there's a lot of stuff here. But the thing that I find most interesting, this is a cotton field west of San Antonio. It's 26 acres. We treated 13 acres of it with the product, 13 acres of it we left untreated. It was created in June last year. So if you look at these sample ID numbers, you see there's a date coded into them. So 8/8 was August 8th of last year that I took the initial sample. So if you look down in the green, so this is the untreated of this treated sample. If you look at the difference, all things left alone, 2.32% organic matter. We treated it, it went to 4.8. Now, I will openly tell you, I don't believe we made that much carbon that quick. This was following corn, but the enzyme load, I would claim that the amount of enzymes and the microbial activity broke down a lot of recalcitrant biomass and made a lot of things available to these plants. So that cotton yielded right at half a bale more per acre. So for a grower, last year, $1 a pound, that's about $250 an acre. So this is real money. So I thought, well, how far can we push this? And there's been no other treatment done. So I went back in January and I said, organic matter showed 3 point. Yeah, there's marginal similar. But the other thing, aside from this difference in organic matter, so in May, it was still 3.5. And now this has a grain sorting crop growing on it. So whenever I go out and sample it, I'm getting roots from grain sorting too. So I'm suspicious that's part of the change in organic matter. But the really interesting thing was, again, this is a pH. It's high 7s bumping 8. So routinely you see, zinc, iron, manganese, and copper are all tied up in high pH environments. Look at the difference in the availability. It's 2 to 3 times. And if you know much about plant science, those are pretty critical things. So this idea of, getting microbial activity, getting some enzymes to help, translates into real world activity. So you asked a while ago about the herbicide piece. So the very same soil sample that I took on August 8th, I split because I've got a little bit of a curiosity about glyphosate. That because I couldn't necessarily always replicate in the US what was being done in the rest of the world. And not to sound like a cocky American, but I think we're pretty good at farming, so I'm figuring out, why can't I do this? Well, we're big consumers of genetic modified crops in the US. So we use a lot of what? Glyphosate. Well, glyphosate has some really interesting characteristics. It's a great chelator. So I'm thinking, well, maybe there's something here. So I send a sample of this to a lab. So this is so that's the glyphosate level in, you'll have to give me the units, milligrams per kilogram. And this is going, again, this is 13 acres in this field. I go out there and I take samples that are about 12 inches all over this side of this field. And then I do the same on the other side. So this is the treated side. I'm sorry, that was untreated. This is the treated side. It's about a 35% reduction in glyphosate in this much soil. Now, if you want to do some rough calculations of, 12 inches of soil at average densities, 2 million pounds, I don't know how much active that is, but and the interesting thing is to make that big a change in that depth, I thought was pretty interesting. And they told me, hey, we can fix this herbicide residue thing. I think that may be, knowing that glyphosate's a great chelator, I think that may be part of the reason why we saw some release of those metals. So, the big thing I guess that I was hoping to be able to show you today was, these changes in you look at organic matter. I mean, this shows we roughly made about a 0.5% gain in organic matter in 1 year. In a hot environment. I mean, I think everybody would stipulate to the hotter it stays, the harder it is to accumulate carbon. So to do that at the latitude that we are, I think is something that we can start working towards and hang our hat on. That if we can do this routinely, this starts making changes in soil health. So this is the farm in Algeria. They have 12,000 hectares out in the middle of the desert. Water that's slightly saline, soil that's slightly saline. And we see wheat. They've done wheat, maize, sugar beet, sunflower, and it all responds similar. Make the biology work, the crops work in a really tough environment. So, any question?
Excuse me, how is the soil treated?
So our preferred method is to apply with irrigation system. Okay. Either pump it into a pivot or through a drip irrigation system. Today, I have not, by choice, worked with very many gathering groups because we have to get the product out of the UV-based mill. I've had some people that mixed it, started fertilizer, and banded it, which it works. I've done multiple times, and every time I do it, I just cringe. Because fertilizer is pretty tough environment, to mix it with commercial fertilizer. In fact, it's not a solubilizing enzyme that's put in with fertilizer, and it's a visual difference.
It's always been a surface treatment.
Yeah, well, not always. I've done, like I said, those trees, I did some foliar. I've done some foliar on some other things, but I really shouldn't have used. So I had in my mind that there's things that can be done. I just haven't covered an area. I do sometimes it's hard to get to the right place at the right time. But I haven't seen what I did on those trees. I'm still convinced that there's opportunity there. But I mean, the product is actually designed for soil application.
You had the soil analytical data. Have you compared those with the plant analytical data? I mean, the nutrients in the plant.
Source tissue sampling.
Yeah.
I've done some.
Because these cells, the zinc, magnesium, chromium, all these are micronutrients. You don't need that much. You increase the capacity in soil. So how can we assess that?
Well, I would suggest that that's something that needs to be done on a broader basis. The thing that I worked in the seed business for 30 years. If you plant grain sorghum
south of San Antonio. I will promise in the field, you can see no crop. There's two things going on, because I worked with Phil a long time ago and figured out how to do it. If you can leave that plant, use 2 or 3 leaves, some manganese, some iron, a little bit of nitrogen. That's enough. And you just can't solubilize it and take it up out of we can help that. And this is, I mean, I've got something close to 300 soil samples. 97% of them on the lab that show deficiencies in there. In what I would call the area I described, southwestern. So Virginia, I work here west, far west, southwestern Arizona. So what we would normally, I would classify as desert type environments. All of them are high pH. And all of them show that iron. So, no, tissue, I haven't done a lot with. Partially because the product is designed for soil. So I'm trying to track changes there. Farmers, I want to see, what my interest is, and again, gets back to, I got a business degree, I'm thinking, how's the money? And we did this cotton field I told you about. We did a lot higher rate than what most farmers would stand still to do. It would cost $140 what we did, which is more than a lot of them spend on fertilizer. So from a commercial standpoint, that would probably significant change in that would make $250 for revenue. It would cost $140 to make $100 an acre. Well, that's acceptable. But some crops won't do that. But we made a change. High rate. We're gonna have to do that every time, or we can be able to do something. All these things start messing with the soil. It took a long time to form, and it takes a long time to be changed. So that therein lies a lot of questions. Continue to work on safe ground where you get attractants. And this carbon sequestration, it's nutrient availability. All of these things all happen together, right? But if you have more carbon in the soil, you're going to have more nutrients.
What about the runoff?
Or it's product good. So, I saw 2 trees that weren't very far apart, and I didn't see the difference. There's one tree. So, I don't think. So the product is also OMRI certified, 100% organic. And now, there's some of the engineered stuff talking about that's not going to be that way. But the product that we sell today, I can sell to an organic producer. So runoff is just, well, those plants did better too.
So what is the rate of application?
Sorry?
The rate of application.
Right.
Yeah, how much do you apply per acre?
So
Is it reasonable?
generally, we do a liter per acre and then a liter per acre. Done, so like with cantaloupes and watermelon producers, we did 3 liters per acre. A liter when it's planted, in 3 weeks another liter, 3 weeks another liter. And it's kind of pushing the idea of, I explain it to people that what do you need 45 days down the road in land nutrition? Counting on biology that I can think right. We're putting some things with it. Put some enzymes in there to make things happen, but you're also counting on improving, the process. It's not, I put nitrogen on it yesterday and 2 days from now it's green, it doesn't happen. So, the way we got to this cantaloupe and watermelon deal was they bloom in 45 to 50 days or start blooming. everything that we want to see in that plant better be there. Because once they start blooming and they start making fruit, it's pulling a lot of nutrients. It's trying to throw out fruit. So, that's kind of the application I was doing it now. On strawberries, we'll put in half a liter. We do that because they're such a good.
How much it cost for 1 liter?
Sir?
How much it cost for 1 liter?
So the gold product full retail is $35 a liter plus, which is what we use on trees and vegetable things. If you go and do the math on that, that gets to be part of that for farmers. But we've been able to show economic opportunity. I had a cantaloupe grower in Arizona. The untreated stuff was making right at 600 boxes an acre. I don't know, I forget how they sell them, they're like 9 or 12 a box. The raspberry treated is making 800. $20 a box, so figure the math on it. It's about $4,000 an acre. But, you know, I think there's that kind of opportunity in the whole notion of soil health in general. I mean, we just haven't figured out. But that's, if I can hang my hat on one thing, like I said, it's soil health, and that's going to be predicated partly because carbon makes water percolate down, and it goes percolate up.
Did you quantify how much carbon was sequestered because of this application?
That soil test I showed you, I mean, that's the closest I can come to quantifying carbon. Just don't have the time to, and, you know, there is lines why we think for someone like y'all, that's your field of understanding for the broader level. Like I said, I'm working on the commercial level. I'm just trying to show a farm.
And also now, when you apply the product for the crop, you may get the yield increase. How about the long-term effect on that, applying the enzyme to the soil? We need to change the microflora over time.
The bacteria is depleted by chemical fertilizers and non phenomena. It's green revolution, we kill the bacteria. What we are doing, we are replacing them back. We are producing bioreactors and replacing the symbiotic, the same bacteria. We don't, besides these engineering bacteria that we have it right now, that one needs to be certified. We are using lots of GMO crops right now, but there are some other companies like us. They are selling engineered bacteria. People Bio is a big company. They are selling engineered bacteria. We are just replacing the depleted one, and it's not going to be an issue. We have to replace them. Because environment is harsh for them. That's why we are applying 2-3 times per season. And the carbon measurement, right now we have an agreement with, I forgot the company's name. We have an agreement with them, this carbon texturing company, and they're going to do that one for us. Because we cannot do that one by ourselves. It has to be done by a professional company.
I think long term, that we have an opportunity to start a carbon market type program based on using our, you know, not just our product. Our crops. We think we can add, part of it.
Algerian project that our president showed it to us in 2018. I was there. I visited the land. It was just I said, "Are you sure I won't spend your money in this desert?" Because there was nothing there. Right now, I think since 2018, they increased the organic matter. I don't know how much right now forecast they're doing. Quite happy, the chief agronomist, quite happy with it.
So does it increase the water retention capacity?
Yes, with the organic matter, yes.
Part of the increase in organic matter caused the increase in biology. I mean,
Is it the increase of organic matter or the development of something like, now you increase the microbial growth? And is it the increase of something like biofilming or something?
Yes, biofilming is one of them, definitely. Biofilm, because during the production in the bioreactor, we have lots of biofilm problems. This is
That will help to retain more water. I mean,
I'm not
we need
sure.
more science.
I don't know about this too much about the biofilm, but I'm sure they're producing some biofilm in the soil. Sure. But since we have lots of enzyme,
That is very striking, the pictures. You desert have full large
this is
plants.
in the middle of Sahara, far from Alger, capital city, in between Niger and Mediterranean, because exactly nothing.
I mean, you can grow
Yeah, now is
plants in Saudi
So what is
Arabia.
the source of water? Source of water, groundwater, how many meters down?
very deep, I think. A drill well, I think it's 300 meters, but the water comes up to 500 meters. But, you know, that's one of the interesting things that, you know, I've talked to several people over there. I was over there 3 times last year. We learned in the US, you can pump your aquifers dry, right? I mean, Ogle Island, Great Plains, is a great example. And that's one of the things that we're speaking of. You need to manage carbon and the crop residue. Because you got to finite the water. That's part of the long-term picture. I mean, you really want to, you have finite amount of water in management. And they don't get enough rain to matter. So water going, whenever they irrigate, they need to go to. That's the problem. But they got a, right now, I mean, literally, they pump water like it's from tomorrow. But they're not really, they want to increase, Algeria would like to increase their farming to 1 million acres. It's their,
How many types of plants you have tried? Plants, which is bottom. How many types of plants you already tried? Applying
a lot. Are several fruit trees. Wheat, barley, garlic, parts of the world.
So the chemical is on the market.
Sorry.
Are you selling the chemical, the recipe? When did you start selling?
Well, I started here 2 years ago in the US. But, Turkey.
no, in Turkey and
In
Algeria, 2018, Algeria, from the top.
And it works only in salt affected soil or? any soil.
That's why my.
I mean, the benefit is only for salt affected soils or any soil, any soil.
I mean, our target's biology, we just happen to, understand that the grants develop some things that, we can help with salt drugs.
Question. The Sahara operation, the sand moves a lot. So what do they do about all that sand being brought in, covering the crops and stuff?
Really.
Before they put burns up. Like that sand that could make the wind. I don't know how that.
Yeah, I mean,
And the dunes and everything, they move constantly.
I have a lot of places.
Yes, and so. I'm sure they're gonna put your money in this.
I'm just.